Thus far, we've discussed how to use the law of sines to solve for an oblique triangle when we are given an angle-angle side, an angle-side angle, or a side-side angle case. For the two remaining cases, meaning when we're given all three sides of the triangle but nothing about the angles, a side-side-side, or a side-angle-side, not to be confused with side-side angle, because the angle that we're given in a side angle side is the included angle or the angle that's in between the two sides. When we have that either one of these two cases, we must use the law of cosines. Now, the formula for the law of cosines is a little bit more unwieldy than the law of sines, but what's really nice about the law of cosines is that there should be no ambiguity, meaning there shouldn't be any situation where we're creating a possible two triangle or no triangle case. It's fairly straightforward, plug and chug, and we should get the correct answers for our solution of our triangle. But I say the word should be because there are ways that we can actually create an ambiguous case for ourselves if we're not careful. But I'll talk about that in our first problem. But first, let's make sure we understand how the law of cosines works. It's simply saying that any side squared is equal to the sum of the opposite sides squared minus, for example, if we were solving for a, 2bc times cosine a. Now, again, looks a little bit more unwieldy, but it's something that after a while we should be able to commit to memory fairly quickly and just be able to solve for. You're probably looking at this and you're probably thinking, oh, this looks pretty darn similar to the Pythagorean theorem. And it is, because if you look at the proof for the law of cosines, it involves using the Pythagorean theorem. And if we think about that, then it's actually pretty easy to memorize. It's simply a squared is equal to b squared plus c squared, which is the formula that we're all familiar with the Pythagorean theorem, minus 2bc, or the other two sides, times cosine of the same angle that we're solving for, or whatever side we're opposite of whatever side we're solving for. So if we keep that in mind, it's a fairly easy formula to memorize after a while. The way that I've written out these law of cosines, these are if we are trying to solve for the sides, I should write that, solving for sides. And if we want to solve for the angles, then we use any one of these versions here. Now, before you roll your eyes and think that we're memorizing a brand new formula, we're not. It's simply a way of rewriting the law of cosines that we're given here. So just really quickly, if I wanted to find a way to isolate cosine of A, so let me actually just move these negative terms over to the other side. So I'm just going to write this as 2bc cosine of A, which is equal to b squared plus c squared minus a squared. And then I want to divide everything by 2bc. So these divide out with one another. Cosine of a is equal to b squared plus c squared minus a squared over 2bc. That's exactly what we have written there. So again, don't worry too much about trying to memorize a brand new formula. You can always try to just solve for cosine of a, and you should have this. So let's actually jump into a problem where we're using the law of cosines, and I want to highlight a couple of different mistakes that we might make in doing a problem. So consider the following problem. We've got a triangle here where we're given all three sides. So right away, we see that we have an SSS case. So I'm going to just go ahead and draw this triangle here. We have an SSS case. So we've got this angle is A, and so I'm going to label this side as side A. This angle is B, so make this 8. This angle here is C, which means this side here is 12. So that's what's given to us. So now that we know that it's an SSS case, I know to use the law of cosines and not the law of sines. Now, right above, I've actually written out some piece of advice that I want to highlight literally for you all because I think it's that important. What it says here is to always solve for the angle that is across the longest side. So in this problem, I would want to solve for angle C first. And the reason why I advise that we do that is because if we solve for the longest or the largest angle first, that's going to ensure that the other two sides, or the other two angles, I should say, are smaller. And we can ensure that they are going to be acute. And if we know for certain that they are acute, then we won't create an ambiguous case for ourselves. And let me start by doing the problem the way we should, but then I want to start from the beginning and actually show you a couple of pitfalls that we might run into if we decide not to follow this piece of advice. So if we're doing this the way that I advise you to, we would say, all right, I want to solve for angle C first. So I would say the cosine of angle C using the law of cosines is a squared plus b squared minus c squared. So a squared plus b squared minus c squared, all over 2 times AB, or 2 times 6 times 8. Now, we can just use our calculator for this. This would be, but if we were so inclined, we can just start writing this out. All over 12 times 8, which is 96. So this is cosine of angle C is equal to negative 44 over 96. So we can say that angle C here would be equal to the arc cosine of negative 44 over 96. And I want to pause here and make sure that we understand, since the fact that we are taking the arc cosine of a negative value, I know that my angle already, when is cosine going to be negative? My cosine is going to be negative when my angle that I'm evaluating it at is in quadrant 2, when it's an obtuse angle. That's the only way that I could get a negative cosine. I can't get a negative cosine in quadrant 1. If I put this into the calculator, I see that angle C is approximately 117.28 degrees. So I'm just going to box that first, because there's my angle. So 117.28 degrees. Now, why was this so important that I started with angle C, the angle that was opposite of the largest side? Well, if angle C is 117.28 degrees, and I know that with all triangles, there's a relationship between the angles and sides, there is no way that angle A or angle B could be anything other than acute. They have to be angles that are smaller than angle C, because angle C, because it's already an obtuse angle, we know that the angle A and angle B have to be acute angles. There is no ambiguity there. And I can just continue now to solve as is. And in fact, I could actually use, since I know, let me just go ahead and erase this, since I know that this angle now is 117.28, I could use the law of sines now to solve for angle A and then subtract both the other angles from 180 to get angle B and not worry about it. And in fact, a lot of students choose to do that because working with law of sines is quite honestly a little bit easier with just less numbers to punch into your calculator. So I would recommend starting with angle C first, or the angle that is opposite of the longest side. Let's say, for example, though, you said, you know what, forget you, Mr. No. You can't tell me what to do. I want to start with whatever angle I want. I don't want to start with angle C. And to that I would say, okay, you actually can. You can start with whatever angle you want. However, you just got to be super careful. And let me show you what I mean by that. And so I've prepared this same problem, and I'm writing kind of what not to do, even though I'm saying right now, you actually could do it this way. Suppose you wanted to start with angle A. You said, all right, I want to actually start with angle A first because it's the very first letter I learned. So I want to start with this angle. And I want to say, all right, if I started with angle A, I could say, all right, the cosine of angle A then would be equal to b squared plus c squared. So b squared plus c squared minus a squared. Okay. All of this over 2 times 8 times 12, or 2bc. And angle A then, just for the sake of time, is equal to the arc cosine of 43 over 48. Again, notice that my argument for my inverse cosine function is positive. Therefore, I'm going to get an acute angle. It's going to give me an angle that's in quadrant 1. So angle A is approximately 26.38 degrees. All right, and we say, all right, in your face, Mr. No, I did it the way you told me not to do it, and I got 26.38 degrees. Now let's just go on and let's continue to solve for the other angles. Let's suppose I wanted to solve for angle C next, and I continue on this path. And I'm going to say, all right, and I'm going to use the law of sines here. I'm going to say the sine of angle C, it's across from the side length C with length of 12, is equal to the sine of the angle we just found, 26.38 degrees, all over 6. And you cross multiply, you do the inverse trig function, you would say angle C then is equal to approximately 62.720. And I want you to pause the video right now and think about this. Is there an issue with what we have just found? Look at angle C and then look at that angle in the context of the side lengths that we're given right now and see if you can recognize the issue. And hopefully after some time you figured it out. You know this angle is impossible. We cannot have angle C be this low of a value. And the reason for that is now, if we look at angle C and we look at angle A, these two angles, if we add these up, we're going to get a sum that's below 90 degrees. And that itself is not the issue. It means that angle B is going to be greater than the sum of these two angles. And why is that a problem? Because if angle B is greater than here, if angle B is greater than the sum of angle A plus angle C, now we've got an angle. We're saying that our largest angle is not across from our longest side. That is impossible. We learned early on in geometry that the longest angles have to be across from the largest angles. The smallest angles have to be across from the smallest sides. There is a relationship there. And so us saying that angle C is this small of a value is going to create a triangle that cannot exist. So what would be the option here? If I went this far, it is actually still salvageable. You don't have to erase everything that you have done. But what we have to recognize then is that angle C is actually not 62.720. Angle C is actually the supplement of this angle. Angle C's actual value is 117.280. And how can we just find the supplement of that? Well, if you think about what we just did, if we said that angle A back here was 26.38 degrees, and we use the law of sines, what did we actually do here? We used this side 6, we used this side 12, and we used this angle 26.38. Does that look familiar to you? Yeah, we used the two sides and an opposite angle. We used the law of sines here. We created an ambiguous case for ourselves. And just like we practiced with the law of sines in ambiguous cases, we just would have to use the supplement here as a triangle that actually exists. So if you don't want to start with the largest angle and you wanted to start with angle A, I would say fine. That's totally fine. You can do that. I would recommend, however, that you then use the law of cosines the rest of the way through. That way you don't create an ambiguous case for yourself. And if you still don't want to use the law of cosines and you want to use the law of sines, despite not starting with the largest angle, that's fine as well. You just always got to remember, do my largest sides match up, or are they across from my largest angles? And if they are not, you want to make sure that you work with the supplements there. So now that we've finished up this problem, so we're going to go ahead and I'm going to just take this work here because this work was actually valid. It was fine. I'm going to just go ahead and take this work here, go back up to my original problem, and let's finish this up. So we figured out angle C, and we figured out angle A. These were our two angles. Oops, don't want to do that. Let's just box this. And to finish this up, let's say angle B now then is simply 180 minus angle A minus angle B. Angle B then, no need to use the law of cosines. We can just go ahead and calculate all that. Would be approximately 36.34 degrees. And again, we could have saved ourselves a lot of trouble had we just started with the largest angle to begin with. And that way we could have just used either the law of sines or the law of cosines to figure out this angle here and then get the third angle by just simply subtracting from 180. So hopefully that helps clarify how to work with the law of cosines. There are a number of practice problems now that you have in your notes for you to work with. Go ahead and check your solutions in Google Classroom. and be ready to ask any questions.